Today I have on Lane Wagner. I found Lane through a course that he did on Free Code Camp that covered HTTP networking, and it is definitely a full in-depth course and highly recommend it. And that's what we're going to kind of dive in today is HTTP networking. And before I kind of get into that, Lane, if you were driving in an Uber or a Lyft and they kind of turned around and asked you, so what do? How would you respond to that?
That's a good question. So these days, I'm technically the founder of a company. I founded BootDev, went full-time on it just 6 or 7 months ago. But what I would say like quickly to an Uber or Lyft driver is probably just that I'm a software developer because it's the easy answer, right? If the question was pushed, then I might explain that I'm in the education space and that I write courses these days and that I used to be a hiring manager and all these things. But the easiest thing I've found is just to say, I'm a software developer.
Gotcha. And with your kind of software education that you do, are there certain topics that you focus on when kind of doing that? Of course, HTTP networking is one of them, but is it mostly front-end related or back-end related, or what's kind of your areas of expertise, so to speak?
Yeah, definitely. Very focused on the back end. So BootDev is a platform for learning to code. Obviously, we've uploaded one of our courses, which is the HTTP course, to the Free Code Camp YouTube channel. It's kind of a video version of the interactive course that's over on BootDev. But yeah, everything we do is very back-end focused. We start students off in Python. We teach kind of in-depth the fundamentals of data structures and algorithms, object-oriented programming, and then we work our way up to more back-end specific topics in the Go programming language, which is where I spent most of my career.
Perfect. Well, I think that provides a kind of good background about yourself, your areas of expertise. And like I kind of said in the intro, today we're going to focus mostly on HTTP networking, as my channel tends to focus a little bit more on the front end, so JavaScript, React, and web development in general. But I still think that having a core understanding of HTTP networking is important really for front and back end developers. So
Absolutely.
That's kind of what we're going to dive in today. And I think a very good first place for us to start here, Lane, is when I say HTTP networking, and as you can see, I can hardly say it. It's kind of hard to spit out of my mouth. But when I say that, or at least attempt to say that, what are we even talking about when we're saying that?
Yeah. So, I mean, HTTP is technically just one way that we can send information across a network, right? Usually we're sending information across the internet. Sometimes we're sending it within kind of a localized network. But the interesting thing about HTTP is just that we use it so much in our day-to-day lives. And as a web developer, 90% plus of what you do will be using HTTP rather than, any other protocol. When you open your browser and you navigate to a website, you're using HTTP, right? That website is using HTTP most likely to load additional resources, to, download user profiles and pictures and all that kind of stuff. So it's just such an important protocol to understand. And it really, whether you're working on the back end side of the stack or the front end, because on the front end, you're going to be making requests, using HTTP. And on the back end, you're going to be writing a server that responds to HTTP requests. So no matter what you end up doing on the web, you're going to need a pretty solid understanding of what's going on with HTTP.
Absolutely agree. And that kind of leads me right into the next question of, with now knowing what it is, why should we really care? Why is this HTTP protocol important to kind of understand?
I guess the best argument for why you should care is just because there's not really an alternative if you want to be a web developer. There are other protocols out there, like I said, for sending information over a network. But if you want to publish a website online, right? If you want to have your audience finding you on Google searches, things like that, there's just really no other option. So I guess the why is almost kind of baked into the what. It's so ubiquitous, It's everywhere, and so you're going to need to use it.
Yep, absolutely. And in your course, you definitely go into several examples of this as well, of why it's important, what it is, and things like that. So kind of with that framework in place, I think a good place for us to go from now is maybe from like a high level. How does this kind of HTTP protocol just kind of work?
There's so many places we could go. Let me try to go from the highest level that I can. An HTTP request is a request response system. So let's say you're browsing Instagram on your phone right? As you scroll through your feed, your phone is making probably, I mean, I'm not an Instagram engineer, but almost certainly making HTTP requests back to Instagram servers asking for individual photos so that they can be displayed, right? So you scroll down to, let's say Ryan's profile picture, right? And your phone is going to send a one-off request back to the Instagram server and say, you know, give me Ryan's profile picture, and the server will respond with that information. And one kind of specific thing about HTTP is that it has this request response. It's not like a persistent connection that stays open, right? Which is something you might be used to if you play like a lot of video games. You might keep a connection open to a server because you're sending lots of data back and forth. But HTTP is this very simple protocol that we can use to just kind of ask for resources one at a time. So it makes our lives as web developers simple in that regard. Give me an image, I get an image back, right? Give me this user's profile information, I get some profile information back.
Gotcha. So kind of from a high level, it's kind of this request response paradigm of you send an HTTP request and then you receive some resource back. And the server serving that request will use this HTTP or the HTTP methods to kind of send that back to you. Does that sound generally like a decent summary there?
Yeah, definitely. I mean, at the end of the day, it's just a protocol, right? So what I mean when I say protocol, that can sound like kind of an intimidating word. But me and you are communicating right now in English, which is kind of just a protocol. We have this agreed upon set of rules for how English works, right? Which letters or characters are available in the alphabet. And that allows us to communicate. So HTTP is very similar. As long as the client and the server kind of agree upon this way of sending data across a network, they're able to communicate over this request response system.
And when diving just a little bit deeper into this protocol, when I hear protocol, I kind of think of something that gives something, this is not a good explanation of this, certain constraints. And this HTTP protocol, my guess is there's probably certain rules and kind of constraints to this protocol of certain ways to kind of make requests and respond to these requests and do different things like that. So when kind of diving in a little bit further, what are maybe some of the rules of this protocol that when you're programming, you kind of have to abide by a little bit?
Yeah, good question. So there's like some rules that I wouldn't necessarily think of too much as constraints. And then there's definitely some like limitations, right? Maybe I'll start with just some of the rules. So like the rules are, well, it works on top of URLs, right? So you're using URLs to kind of specify which resource you're asking for in your request. It uses methods, so things like, get requests versus post request versus put requests. And then there's a specific way to kind of send data in your request. So you can send data in a request body. You can send data in the request headers, in the request query parameters. There's actually quite a bit to it, which is why it's a 5-hour course. But there's lots of different ways that you can kind of structure the data that you're sending in the request and structure the data that you get back in the response. The limitations of HTTP, which there definitely are some, is kind of this base version of HTTP is built for request response, right? So it's kind of one-off requests. You wouldn't use the most basic version of HTTP for anything like persistent or high performance, which kind of brings us to the second point, which is it's not a particularly performant protocol. It's a little bloaty. There's a lot of kind of requests going back and forth in the interim to like do things like security handshakes and cryptography to make sure that requests are secure. So, streaming platforms often will use a different protocol or will do some other stuff basically to kind of get around some of these limitations of just your standard kind of get and post requests.
Gotcha. Yep. And I think maybe a better way to frame that question would have been, instead of using the word constraints, that kind of comes across as limitations, I would just say common ways to use this HTTP protocol. And you kind of touched on it there, to where you're going to use the different HTTP methods of get, post, put, patch, head. There's probably some other ones that I'm not thinking of. And you kind of use these methods to kind of send data back and forth between a client and a server. And kind of with that, You mentioned there that HTTP works alongside URLs. Could you maybe explain what you mean by HTTP working alongside URLs?
Yeah. So, not every, well, let me put it this way. Lots of protocols use URLs. HTTP is one of those protocols, right, that cares about URLs. So when you go to, let's kind of start from like this top of the stack. When you search for something in Google, right, what's the name of Elvis's dog, right? You get back this list of websites, and each one of those links in Google's search engine results is a URL, right? And when you click on that URL, all that's really happening is you're taking that URL and you're telling your browser to make an HTTP GET request to the URL and to render the response, which is a set of HTML, CSS, and JavaScript, render that in your browser as an interactive website, right? So you kind of used GET requests to download all these assets for the website. Now, while you're browsing the website, it's very likely, if the website isn't just a completely static site, if it's something a little more interactive, right? Imagine an app like YouTube or Zoom or Twitter. Those kinds of web apps are probably using additional HTTP requests while you're browsing the site to do extra stuff, right? So like if you change your password, you might send a post request to change your password or a put request to change your password. You might send a delete request, right? If you want to delete a tweet or something like that. So these HTTP responses will continue being sent while you're browsing websites.
Gotcha. Totally makes sense. And when we kind of use the terminology of like sending requests and receiving requests, like what do we kind of mean by that? Like, are we literally sending data across like a wire to the backend to respond to this, or what does that kind of look on a lower level there? Like, are we sending like little packets of data, or what's kind of going on there?
Yeah. So the nice thing about HTTP is, as a developer, you can think about it kind of from the highest level, which is like you can think about your entire request as one giant block of data. You can say, I'm sending this entire request body, right? If you're familiar with the JSON payloads, you have this giant JSON payload and you're going to kind of send it all at once. And on the other side, the server can kind of treat it the same way for the most part, at least at the application layer. Under the hood, there's a lot of stuff going on that you just don't really need to worry about too much as an application level developer. But yeah, basically under the hood, that bunch of data will be broken down into chunks, into binary, and sent across a network kind of individually and then reconstructed on the other end. And the way that works like varies depending on a ton of stuff. But that's probably like a whole nother conversation that, again, as a web developer, you just need to know that it's happening. You don't necessarily need to understand every intricacy of the networking stack.
Absolutely. And the only reason I kind of asked that is just from a kind of like interesting standpoint, to where when I first realized that the internet is literally like these connected wires that you're sending data across all throughout the world, it was just pretty wild to me. So just wanted to hit on that. But yeah, if you're listening to this and learning about this in regard for web development, you really don't need to know how it's literally working on that low of a level. You just need to know that for these HTTP request responses, you can send them using different JavaScript methods and then return using different Python methods and stuff like that. So kind of along that same note, if you're kind of working on a client, say using JavaScript, how does someone like actually make one of these HTTP requests?
Yeah, there's different ways to do it. The way I teach in my course is using the Fetch API. So the Fetch API is essentially a set of functions and objects that are built into your browser. So you don't have to install any additional libraries to be able to use it, generally speaking, as long as you're on a fairly modern browser. But yeah, the API is built into the browser. So you have access to these functions that, again, allow you to work with HTTP from a very high level. You pass in a body as a JSON object, right? Things like that. Fetch is one option. There's definitely other options. Axios is another one that people use. I'm a fan of Fetch and tend to prefer it, again, just because it's built in most places. But you do run into issues if you start running JavaScript in other places. So for a long time, Node, which is where you'd run JavaScript either kind of on your machine outside of a browser or maybe on a server, didn't support Fetch. It has recently started supporting Fetch experimentally, so I use it there as well. My guess is it will stay, but it is technically an experimental feature, so we'll see. But yeah, you'll typically work with HTTP through these APIs. I teach a lot of Python and Go. In Python, there's a requests library that you'll typically use. In Go, there's a net HTTP package. Pretty much every language has kind of standardized ways for accessing the networking stack without having to rewrite it all from scratch.
Gotcha. So when thinking about actually working with HTTP requests, most of these languages and frameworks already kind of come built in with certain ways of handling these requests and responses. And in JavaScript, like you said in particular, you can use the fetch method to make these requests. And, I don't want to get like crazy low level here, as with mostly audio podcasts, it's kind of hard to kind of visualize some of this stuff. But let's just say that someone is working in JavaScript and there's this API that they want to send a request to and just will return some data back. How would that kind of look if they're writing this out in JavaScript? And maybe also like say that you created that API, how would it kind of look if you wanted to be the one actually returning and responding to that request, kind of from the server side perspective?
Yeah, good question. I'll try to I'll try to say it as verbally as I possibly can.
Yeah, it's hard to do. And in Lane's defense here, it's a difficult question to answer, and try to also consider most people are probably just listening to this or have it on in the background. So good luck, Lane.
Yeah, no worries. Okay, so you've got this fetch function. It is literally a function in JavaScript called fetch. It's built into your browser, so you don't need to define it yourself. So in your code, you would call this function, and what you pass in depends a little bit on what you're trying to do, but let's just say you're trying to post some data to a server. So maybe you're creating a new user on a server, right? You would be passing in a URL as a parameter. You would be passing in the HTTP method you're using, which is post. You may or may not be specifying some custom headers for the request, maybe like an authorization token or something like that. And then you would pass in, most likely, assuming that you're using JSON as kind of the structure for your request body, you would pass in a JavaScript object with some key value pairs. Things like, first name is Lane, email is, whatever. All that data is going to get specified in the parameters to the function. What that function returns is a promise. So if you're not familiar with promises in JavaScript, I don't want to go like way off the rails here and dive into that. But basically, the promise allows you to kind of wait for the request to come back, because it's not going to happen instantly, right? We're talking about data being sent over potentially continents. So you have to be prepared to wait. So the promise comes back, and then you have to await the promise. If you're familiar with the async await syntax, or you could use .then to register a callback on the data. But essentially, once the promise resolves, you're able to parse the request object, which is, again, a built-in object to the browser, and you can kind of dig in to all the little bits of the request, the things like the request response body, the response headers, status codes, all that kind of stuff.
I think that provides a great example of making that request to kind of this API. And then I would assume if you're on that API side or you're on the server side, it works in a pretty similar way to where you kind of set things up to receive requests, you handle that request, and then you make this HTTP request back by calling some sort of function. Like in Python, you mentioned the request library that you can use, and kind of follow that kind of similar HTTP protocol to return that data back. Does that sound about right?
Yeah, it's similar in the sense that you're probably using some sort of library or package. The difference is in the way you think about kind of the way the code is set up. So on the front end, you're executing code as the user does stuff, usually, right? When the page loads or when a button is clicked, you're going to like make a request. On the back end, rather than being active, you're being reactive, right? So basically the way that you set up your backend, and I'll just use the example of Go because that's primarily what I teach, you're essentially setting up handler functions. So you'll define a function that says, I want this function to be called when I receive a GET request. And it takes as inputs kind of the HTTP request and some way to write back the response. So, when a GET request is sent to this specific URL, this function on my server will be called. And until then, my server just kind of sits there waiting for requests to come in, right? But when that request comes in, my function is called and my logic executes and I can respond with some data. So it's just kind of a little bit different in the way that you set up the code. And depending on which framework or library or language you're using, there can be a more or less magic involved. In fact, that's why I teach Go, is because in Python with APIs like Django and Flask, they tend to, in my opinion, obfuscate a lot of what's happening. A lot of it's kind of just magic and convention. There's nothing wrong with developing that way, but I find it really hard to teach that way and to understand what's going on if you go too high level and allow your framework to do too much work for you, at least right out of the gate.
And I would say from firsthand experience, for my company I work for, we use Django, and me being primarily front-end oriented, it took me a while to figure out like what's actually going on with Django after just like looking at the code and trying to understand how things are working. Like, it's not, like you said, it's a little bit black boxy to where there's quite a bit of magic happening there. But I think that provides a really good kind of framework for thinking about it, in which, similar in the sense of when you're responding on the back end, similar in the sense that you're still using the HTTP protocol and you're probably still calling some sort of function that comes from some sort of built-in package on that language or whatever it might be, but different in the sense that rather than like proactively saying, hey, post this data to the server on this certain event, you're kind of just hanging back and waiting for a certain URL to be hit or certain things to like that to handle those network requests that are coming in, and then returning some data there. So I think that's a really good way to think about it. And maybe kind of jumping back to making these requests on the front end, one thing that you mentioned was kind of using asynchronous JavaScript. And in your course, you go over this very well and kind of dive into this deeper. And I also have courses on promises, and like there's hours and hours and hours of content on this. It's not the most easy thing to necessarily understand, but there's a lot of content out there, and we're not going to cover all that here. But one thing that I do think is maybe important to cover is that when making these HTTP requests, you are making them across a network. Like we kind of mentioned earlier, there is actual literal data being sent across the network. Sometimes it's traveling very far, and this takes some time. And with that, since JavaScript is like this single-threaded language, and these requests take a lot of time to make, when you make these requests, are they like blocking your JavaScript program so it can't do anything? Or does this kind of lead into what you were talking about earlier with promises and maybe doing this in more of a asynchronous way?
Yeah, this is a great topic. I recently published a video on this topic from the server side, but it's really important to cover. Basically, JavaScript is single-threaded, I think, as most of us know, which means if you have like 4 processors in your computer, JavaScript's going to take, sorry, not 4 processors, 4 cores in your processor, a better way to say that. JavaScript's only going to take advantage of 1, right? Which, when you're dealing with the web, usually isn't a problem. You tend to be very I/O heavy, which means you're sending probably a lot of data over the network, but you're maybe not doing a lot of computations in your CPU. So JavaScript tends to work pretty well. The reason that it doesn't block, like you said, and kind of your computer doesn't freeze up or your browser doesn't freeze up while you're waiting for data to come back, is because JavaScript has some built-in internals that kind of allow you to defer what's happening on a kind of given piece of code. And that's what promises are, right? And like you said, there's, we have courses, we have videos that you can go check out if you want to really dive into concurrency and promises. But the basic idea is when you call that fetch function, you're telling the JavaScript runtime, start this request and then move on. right? Start this request and then move on to the next thing and do some other stuff for a while, right? And then later, when the response comes back, you can pick up here in this line of code, right? So you're just allowing the JavaScript runtime to move on until, something happens in the future. In this case, the thing we care about is the response coming back.
Absolutely. And I think that for me, when I was first learning about JavaScript, it didn't particularly make sense to me why we needed like asynchronous JavaScript. Like you mentioned, you make this request and you kind of come back to it at a later point so you don't block this JavaScript thread. And initially I didn't really understand why this is important until I learned about, okay, well, when making these requests across a network, it takes time. And since it takes this time, you don't want to block this JavaScript thread and block your program until it kind of comes back. So I think this was kind of an important thing to touch on, in that when making a lot of these requests, you can do them asynchronously. And there's kind of other ways to do them in other languages and stuff, but you can do them in ways that don't block your program and allow things to kind of continue. And you looked like you're going to mention something there.
Oh yeah. I was just going to say it's worth pointing out as well that JavaScript's the weird one here in terms of how it does this. Most other languages are synchronous by default, right? So if you call the fetch function, regardless of whether you use any syntax, what's happening is you're sending a request. And then, if you care, you can wait for the promise to resolve and deal with the response. But by default, JavaScript's going to send that request asynchronously, because anything else would be catastrophic. The browser would freeze up, right? In any other language, pretty much, I shouldn't say every language, but most other languages like Go or Python, your code will sit and wait and block for the request to come back. JavaScript is unique because it's so domain specific to UIs. Because in other languages, that isn't really a problem. You probably want to wait for the request to come back. That's why in JavaScript you're using the await keyword. It's because you want to wait. So it's just something interesting to point out. If you do move beyond JavaScript into some other languages, that you'll see this other way of dealing with requests.
Yep, absolutely. I think definitely from other languages, when you start getting into running things potentially in parallel or with multiple threads, there's definitely a lot of different ways of kind of doing things other than just this single threaded way that JavaScript tends to handle things. And with that, I think, Lane, you've provided a ton of helpful information here, and it really just provided a nice overview of HTTP networking and just kind of how things work from a networking perspective. But if people want to kind of dive in deeper to learning about HTTP networking, and they want to learn more about kind of what you're doing and what you have going on at your website, where should they kind of go?
Yeah, definitely. The best place to find my resources is on boot.dev. That's the name of the site and the URL of the site. We teach everything backend, right? And we do that in Python, JavaScript, and Go. And really the JavaScript portion actually is just for that kind of HTTP networking part, because it's so the fetch API is so important to understand whether you're on the front end or the back end. I kind of choose to introduce JavaScript just for that purpose. But yeah, boot dev, if you're interested in the courses and the content and the projects, you can also find me on YouTube at boot.dev, Twitter, same handle. Love to connect with you. Perfect.
And just as a quick note here, for a lot of people watching this, they might be a little bit more front end oriented. I'll just say that also understanding how the back end works, at least from a moderate level, and understanding kind of the inner workings of that, is definitely going to help you out when you're actually solving problems for your job, and maybe you need to do a little back end and stuff like that, and it'll just make you a much more kind of powerful programmer. So definitely recommend those resources out. And yeah, thanks for coming on, Lane. I really appreciate it.
Thanks for having me, Ryan. This has been good.